Hey everyone, so welcome back to my channel. So in my previous video, I have introduced to my power supply which I have built on my own. So first I would like to I would like to apologize from you guys because I was unable to make a video on this. So let me tell you what I have done. Although I have made a video on this, you can go and check that link out. I will be provided that link in the description box. But today the reason behind this, I'm making this video because in that videos I have not clearly discussed that what I have fit and how do I made this power supply. This is a DC high ampere battery charger. This is a 12-volt battery charger which gives output voltage of 14 volt and 10 amperes. For this I am using a UPS transformer which I have taken from old UPS and fixed 4 wires as you can see here, and these are two alligator clips. So basically in this video I will be going to show you how you can make another a battery charger of 6 volt and up to 10 amperes, 6 volt 10 amperes with this UPS transformer. I got this from my nearest electronics market. I got this around 150 rupees. I'm telling this around 150 rupees because I'm not holding the price of the main UPS circuit board, so I'm just holding the price of this main transformer. This is a step down as well as a step up transformer which also generate high voltage AC current as well as convert high voltage to low alternating current to charge the UPS battery of 12 volts 7 amperes or 12 volt 14 amperes. So before starting my video I would like to remove this battery charger which I have made previously. So in this video we will just focus on the new project. So I'm making this I'm making this as for my new in the upcoming videos. I will going to use this to power my a cooler which I'm going to make in my future videos, and I hope I will able to make in few days or in few months, I hope, because my board exams are knocking at the door. So I hope that I will be able to make, and I really need to focus on my exams because exams are more important than making this type of projects right now. In this video I will check the voltage output of this transformer, which will be this. This is the primary winding and this is the secondary winding. Primary winding means the 220 voltage will be get connected on this wires, and the output, which will be a low alternating current, will be this. But since the ampere will be very high, so the wires are made very thick. So to input the alternating current in the primary wire, we need to take this black wire as a common, and these three are the difference. Means we have to make this black as a common, and we can take yellow. In next part we can take green by making the black common, or we can take blue by making the black common. So we will get different alternating voltage if we connect different colors of wire. So I will demonstrate the voltage by using my digital multimeter. I hope you have seen this digital multimeter several times in my video. So I connected this. These are my new probes of this multimeter, which I have brought today from my local electronics market. It took me around 60 rupees. The the shopkeeper also have a good one than this, but it was too costly for me because it cost around 120 rupees. So I thought just for the rough use I think I should use this low cost 60 rupees probes. So I brought this one and going to use this is my extension board. I will be give the alternating current to this transformer from this board only. And yeah, let's start. And I will be also showing you how to make a bridge rectifier, a full wave bridge rectifier, DC AC to DC bridge rectifier in this video with 10 ampere diodes and capacitor as well. Because if you want to make a full wave bridge rectifier, we always need a capacitor to make it a full wave. Okay, so I will be first starting this video by showing you the schematics, and then I will go on to the practical. So keep these things, I will keep these things apart and come to the theoretical part. So if you take this transformer at first, I will give the heading as UPS transformer. Let me focus on the page. Yes. So now I will start the project with my schematics. So first I would like to clear the basics that the full form of UPS is uninterruptible power supply, or you can say uninterruptible power source. So a UPS is basically made so that the work you are doing on your computer can be carried on when the house current gets off or turned off by the main power supply or by the mains. So if you don't know, please learn from this video that a transformer works on the law of mutual induction. So I am going to draw the transformer here. This is the symbol of the transformer. Now I have four wires. I have four wires in the input as a primary. Here you can see yellow, black, blue, green. So as we know, as I told you that black should be common. So I am taking the black. I am taking this as a black, I'm calling it as a ground. But it's not a ground because as we know, alternating current do not have a ground. It changes its frequency at a regular interval time in a very short period of time, because the alternating current which we get in our house is 60 hertz. Means if we do manually, we have to change the polarity of the alternating current a number of 120 times in 1 second, which is just impossible. So to do it manually, we use MOSFETs, which is a very high frequency switching thing. But in household we get a 60 hertz frequency of alternating current. So I'm holding this as a ground since this is a black wire. So let me fix this as here. Yes, black wire. So now we can see we have a green wire. I'm writing this as green. Then we have a blue wire, then we have a yellow wire. I'm writing this as a input primary coil. This is the output with a thick wire. So this is the output, which will vary the voltage of the alternating current of the output on this wires. So if we take ground and green, we may get a type of voltage. I'm marking this as V1. Ground, if you take ground and blue wire, we can get some amount of voltage which will measure, uh, which I will measure in future, but in this video only with my multimeter. So don't worry, I will measure the voltage and show you the practical in this video only with my digital multimeter. So we can get another voltage which may be different from this one. So I'm marking this with 1 and 2 to different, to make them different. So if we take ground and we take the last wire yellow, we may get another type of voltage in the output wire. So since this is output, I am marking this as O1 and O2. So now we'll go to the practical and we'll mark the value which we are getting by giving the alternating current input of 220 volt to 250 or 240 volt AC. This is a symbol of AC current. Please remind that if you some of peoples have a misconception that if we give a input of 220 volt alternating current, the output will be 12 volt or 5 volt or maybe 6 volt DC current. No, that is very much wrong, because a transformer is always converting the high alternating current to a low alternating current, or a low alternating current to a high alternating current, on the principle, based on the principle of mutual induction. So to convert it from AC to DC, it varies from 1000, it can be to 220, it can be 12 volt, also it can be 5 volt, but a AC can only be converted from AC to DC only by using a bridge rectifier. You can make a bridge rectifier as a half wave, 2 wave, or a full bridge rectifier by making 4 diodes, by connecting 4 diodes, and to make it fully rectify it, you need to connect a capacitor to remove the sharp edges of the waves or the shaft peaks which is left while you are passing alternating current through a diode. So after doing that, the waves will be fully rectified and the AC will be fully converted into DC. So now I will just pause this video and I will just fix all the components, and I will show you how you can change the alternating current into low alternating current by using a high ampere UPS transformer, which is this. Let me show you the background of this transformer. This is a Frontech UPS transformer. You can see the model number. This is a 725, model number JIL2526. Warranty void equals to that is another thing. We don't need all this. We just need to see that transformer is working in condition. If the transformer is not working in your UPS, please don't try to change it, because this type of transformer is very much costly if you buy a new one. If you don't need to do that. If you want a new UPS, you can buy that, because the amount of money you will waste on this transformer to change to get a new one, you can get a new UPS in that money. So I will recommend you to buy a new one if the transformer is not working or damaged. So let's see the practical. So right now I place this transformer at a stable platform. I'm going to use this wire, 3-pin wire. I'm not going to use this ground port. This is the neutral point. This is the phase point. So as I told you before, that this is the output. Don't give the 220 volt in this secondary coiling. Your transformer will get damaged, and the amount of money you have spent on this will be get wasted. So these are the input wires. So I will take my copy beside my project, and I will jot down that what voltage I'm getting at a variable um, points. So I will, as I told you, I will going to take this black wire as a common and the other color wire as a variable. So first demonstrating or first continuing this video, I would like to strip this wire so that the process gets easier for me as well as for you to understand. So let me do this. Yes, I've stripped this green, black, yellow as well as the blue. Just let me give few minutes to make them nice condition so that it be helpful for you guys to understand in a very nice way. So I'm going to take this multimeter and put in the alternating current option. So right now you can see it is showing 0 voltage since I have not given an input. So I need something to hold this right over here. So here these are the two probes. You do not need to enter the black into the black and the red into the red, because as we know that it's the alternating current always changes polarity at a regular interval of time. That's why we guys do not use the alternating current in the making of electromagnet. Yes, we can use the alternating current in making electromagnet, but we always need a bridge rectifier to make it in DC. But that is also same thing, that we need DC current. We cannot carry on with alternating current. The DC needs to be halfway full wave. That's not a matter, but the current should be DC current. So before starting the video, I will just starting this demonstration, I because I have started the video a long period of time ago, so I cannot say that let's start the video. So first I will show you the voltage which is coming from my house. So this is, I'm on this thing, and please keep an eye in the multimeter. So I will put this thing, and here as you can see, I hope you guys can see clearly that it's showing 200 volt AC. I will show here also so that you don't have a confusion. 200 volt AC, here also 200 volt AC. So I hope you are clear right now. So next go to another part, which is the output voltage, which is the main part of this video, for which you guys are watching my video right now. So here, and right now I need my main power cables, which I'm going to connect in my extension board right now, which is connected. Safety first, you should wear a slippers or create a wooden resistance on your legs, so that if a incident occurs, you may not be in danger. So you should not be in danger. So I will going to take this black as a common, and please keep your hand away from this naked metallic body. So first I will do with the yellow wire. Please, if you're underaged, under 10 years old, please do not perform this project. So I will on my, now you can see it is giving output of 6 to 5 volt. If I put in the 200 volt AC, we will get an actual voltage in points, decimal points. So I'm getting output voltage of 6.2. Let's jot it down on my copy. So we are getting in the competition of in the complexion of yellow and brown, we are getting 6.2 voltage right now AC. So AC 6.2 voltage I'm getting right now. So I will switch off this power supply. Before connecting the another wire, please take your plug off so that the connection gets uh, disconnected. And again I'm going to take the black as a common. Yes, and again connect this another wire which is green color. Please see that, please make sure that the wires are not connected with each other, or if it is connected, your MCB, or if you have a fuse, it can burn out and you can harm yourself. So please make sure that you don't do that. And right now I'm again going to switch on the main power supply, my AC current. So all the wires are not connected with each other. Please make sure before giving the alternating current main power supply to it. Okay, let's on the power supply. It is right now giving a 5.3 volt alternating current. It is with green and black. As I was telling you that it will give a different volt at a different point of time. It is giving 5.3 with yellow. It was giving 6.2 alternating current, and right now I just left to see what voltage it gives with the blue. So again I will disconnect the connection, and again I'm going to replace this green with the blue. Please, I'm again requesting you guys, please maintain the safety. Yes, the connections are established, so I've connected. Make sure that the wires are not connected with each other. I'm telling this repeatedly after connecting every wire, because the safety is first when you do projects with alternating current. So let's on the supply again. Now you can see the humming sound which is coming from the transformer. This is because it is giving the highest which it can give right now, so with a very high ampere. So right now it's providing a humming sound to me. Not me, it is providing a humming sound. I hope you guys can see. Let's check this with a tester. So no, it is not. I think there is. Let's alter this points and let's check again. Maybe we have connected the wrong ends. No, the connections are okay. This is the problem with the transformer only, or maybe the since it's giving the highest voltage it can give, for that reason it is humming. And the main voltage which we need, it is 7.6 approx, the highest it is giving. So I will again jot this down. So I'm getting us 5.3 volts when I'm connecting ground and green color wire. I'm getting 7.6 volt. I'm connecting ground and blue wire. I'm getting a 6.2 volt alternating current when I'm getting yellow, when I'm connecting yellow and ground wire. So please make sure this all the voltage which I've told you right now are all in alternating current. So now I will put this transformer, multimeter and the other thing with which I'm sitting right now, and come to the topic, how to make a bridge rectifier, a full wave bridge rectifier. So let's start. Now let's start. So before starting this video, I've just seen the time of this video. It's gone too long, up to 30 minutes. So I will not make this video too long so that you don't get bored. So see this video. In this part, I will just show you how to make this diode, bridge rectifier diode, and continue building the power supply in my next video. I hope I will able to make that video very soon, and I promise you I will make this video for you guys very soon, in within 2 to 3 days. So as I told you, theory is very much important than doing practicals. So first I will show you how you can make the bridge rectifier in my in your copy. So before making a bridge rectifier, I would like to show you what is the symbol of diode. So our diode look like this. I hope you guys have seen a diode before. This is called anode. This is for the plus. This is called cathode. This is for the negative. So the main symbols which is used in schematics is this is cathode, this is anode, positive, negative. So during a bridge rectifier, always remember in a very simple way that make two anodes at one side, make two cathode at one side, like this. I'm making this like this, taking two cathodes and joining them with each other at one end, and again taking another anode and cathode at one end. I'm very sorry for my drawing right now. So these two are this is I think for the DC, and I don't think this is for the DC only. This is for the DC, and this are for the AC. Always remember the point where the cathode and anode are meeting but not equal with each other are AC inputs, and whereas cathode and anode, this is for the positive, this is for the negative. So let's start making. For this, making a bridge rectifier, I'm using high ampere diodes. I got this 4 rupees for each. If you go in local market, you may get in 4 to 6 rupees, but these diodes are not costly more than 6 rupees. So maintain this price and make sure that the shopkeeper always gives you in this cost only. If he is not giving that, he is cheating on you. But I think you should not buy from online stores, because they take a very high cost for delivering this type of diodes. So for this project I'm using this number diode. Let me focus. This is a 6A, this is 6A4 MIC. These are 10 ampere diodes. It can handle a load of maximum 10 ampere. So as I show you in this diagram, I'm going to take two cathodes and two anodes. Since these probes are a little bit thick, I'm going to use my plus, this pliers, and rotate them. Like this way, in this manner. I will always tell you not to do soldering on this type of diodes, because these are very thick wire, thick proofs diodes, so that the soldering will be not applicable on this. If you have a high power soldering iron, you may try, because nothing is impossible. So it will happen, but you need a very high power uh, soldering iron. But the ones who don't have, they can apply my method and connect a wire and rotate them in like this way. This is also applicable if you want to connect the wires. If you have a high power soldering iron, you can also apply soldering on this. So the two are ready right now. So as I told you, you can see two cathodes, two anodes facing with each other, and connect. And now I will connect in this manner, so that one cathode, one anode, one cathode, one anode. So right now our bridge rectifier is ready, but it is not a full wave bridge rectifier until and unless we connect a capacitor. So we'll join this component in my schematic diagram. So the symbol of capacitor is like this. Some of you guys can think why I'm drawing the symbol of battery, but this is not a symbol of battery. The symbol of battery is like this. One end is bigger, one end is shorter. This bigger one is negative plus positive, and this is a negative. But here you can see I'm drawing them in a very equal size like this. So it will be like this. Please make sure about the polarity. If you put them in a wrong polarity, the capacitor can get fused, and your bridge rectifier also may get damaged. So this is uh, 4000, let me focus on the number, 4700 microfarad capacitor, and this is a 50-volt capacitor. I think this is the best capacitor we should use in this type of projects. So right now I'm ending this video over here, because it became a very long video of 30 minutes and 32 minutes approx. So let me end this video right over here, and in the next video I will show you how you can connect this capacitor with this bridge rectifier diode which I have made in this video, and also connect that transformer which I have shown you before. And also I will try to cover that how to make a air cooler and fix and use that transformer as a high voltage, a low voltage but a very high ampere power supply to power that air cooler. So thank you for watching till here. If you are new to my channel, please subscribe it, please share this video as much as you can. And till then my new video comes, please stay tuned, and thank you. Good night, and Jai Hind, Jai Bharat.